All right, so number 2, yes, that's a good one to start with because there are a number of things that you need to figure out about this problem, okay? First thing they want you to do is figure out the height of the larger cone. And what you should notice is that since the radius of the larger cone is 4 times as big as the radius of the smaller cone, that means the height of the larger cone is going to be 4 times as big as the height of the smaller cone. However, they don't tell you the height of the smaller cone either. So how can we use this information that they gave us? Okay, nice. So we can use the Pythagorean theorem to find the height of the larger cone. So, right, then it is a multiple of a 3, 4, 5 right triangle. So if you can see that, that will save you some time. If you can't, you have to do it the old-fashioned way. So that tells you that the height squared is going to be, what's 400 minus that? 256, which means that the height of the bigger cone is 16, okay? So now you can put that together with what I said before, which was that since the radius of this cone is 4 times the radius of the smaller cone, that means the height of the big cone is also going to be 4 times the height of the smaller cone. So the height of the smaller cone is 4. Okay, right. Because that is a 3, 4, 5 right triangle. Good. All right, then it says figure out the volume of a large cone. We have not done this for a while, but we did do an example with this yesterday. So you should remember what the volume formula for a cone is. Pi r squared times the height divided by 3. Good, and we know all of those pieces already. So we can go, the radius is 12. So we can go pi times 12 squared times 16 divided by 3. And if we leave that in terms of pi to make it easier, you come up with 768 pi centimeters cubed. Okay? Same dealio for the small cone. Pi r squared times this time the little height divided by 3. So we know that the radius of the smaller cone is 3 because they tell us that in the book. We figured out that the height of the smaller cone was 4. And so if you crank that out, you get 12 pi centimeters cubed. Okay, so believe it or not, we're still not done with this problem because the last question they want us to answer is what is the ratio of the volume of the large cone to the volume of the small cone? There's 2 ways that you can do that. Since we know the volumes, you could just divide these 2 things if you wanted to compute the ratio directly. Right, but since we know that the ratio of the heights is 4 to 1 and volume is cubed, that means the ratio of the volumes is going to be 4 cubed to 1 cubed, or 64 to 1. Okay? So lots of stuff in there. Great problem. Would make a great test question.
Test question?
Oh, yeah.
No.
Definitely. All right, so keep going. Number 3. Okay, so number 3, this time they start out by giving you the ratio of the areas, and they say that that is 9 to 25. And the first question that you're asked to figure out is if the ratio of the areas is 9 to 25, what would the ratio of the heights be? Well, area is squared, right? So if I start with the ratio of the areas and I want the ratio of the heights, I square root it, go backwards. So the square root of 9 is 3, the square root of 25 is 5. So the first part of that answer is that the ratio of the heights will be 3 to 5. Okay, you understand how I got that? Square root of both those numbers. Colton?
So you can, like, the height counts as a side?
Yep, the height counts as a side. Yeah, so I really shouldn't be saying ratio of the sides. I should be saying the ratio of the dimensions, because it's any dimension, the height, the radius, the diameter, the median, any of those things will work, okay? All right, so then now that we know the ratio of the dimensions, what's the ratio of the volumes? How do I figure that out? Right, I cubed these. So 3 cubed is 27, and 5 cubed is 125. So the second part of that is that the volumes are going to be 27 and 125. But actually, it looks like in the book they have that flipped around. It's the volume of the large one to the volume of the small one. Either way is fine. Okay? All right, then it says find the volume of the large prism if you know that the volume of the small prism is 324. So does the 324 go on the top here or on the bottom?
Bottom.
It goes on the bottom because they said the small prism. Yeah, so that's 324. Oh, okay, that's fine. You get the same answer either way, right? So if you cross multiply and divide, you find the volume of the small, or the large prism, sorry, should be 1,500 centimeters cubed. So this is an answer, this is an answer, and this is an answer. Okay, so that is also a good question. And that actually is one that you should be able to figure out. Start with the area, square root it to get the sides, cube it to get the volume, and then use that ratio to figure something out. All right? Okay, now what? Just keep going. Keep on rolling.
Just keep
All
going
right.
4 then.
Keep on rolling. All right, number 4. It says these right cylinders are similar. It says the volume of the large cylinder is 4,608 pi, and we need to figure out the volume of the small cylinder. Well, lucky for us, they give us all the dimensions we need to know that. The radius is 9, and the height is 24. What's the formula for the volume of a cylinder? Pi r squared, right, times the height. Okay? So we can take the information that we have right here and figure out the volume of this cylinder directly, right? Because what's the radius? 9. So we can go pi times 9 squared times what's the height? 24. And that's an equal sign, sorry. Okay, and so if you multiply those out, you get 1,944 pi feet cubed. Okay?
Is that it?
So that has nothing to do with anything we've learned in this section or this chapter. That's just plain old, use the formula for the volume of a cylinder to figure out the volume of a cylinder. Okay? For that first part. Now it says, what's the ratio of the volume of the large cylinder to the volume of the small cylinder? And they told us the ratio, the volume of the larger one is 4,608 pi. We figured out that the volume of the smaller one is 1,944 pi. So the pi's cancel. And because I've got a skedaddle here, I won't make us suffer through all the reducing, but if you divide by 2 and then divide by 2 and then divide by 2, this works out to be a ratio of 64 to 27. Okay? So the ratio of their volumes is 64 to 27. So, yes.
So when it says like the volume of the large prism or the volume of the small, it just wants us to write that.
Yeah, it just wants you to write the reduced fraction, okay?
5.
All right, so if we need to figure out something about the height, we need to reduce that down to the ratio of the dimensions, not the ratio of the volumes. So what would the ratio of the big height, so the little height, be if the ratio of the volumes is 64 over 27? 4 over 3, good, because the cube root of 64 is 4, and the cube root of 27 is 3. So now you can use that to figure out the large height, because we know what's the small height. 24, that's right here. So the big height is going to be x. So you cross multiply, then divide, and that tells you that the height of the larger cylinder is 32. Close, 32. Okay, so answer right here, the answer right here, and the answer right here. So these are awesome problems because of all the work that you have to do. All right, 5, 6, and 7 are gimmies. We can get through those really quickly. It says the ratio for number 5, the ratio of the lengths of corresponding edges of two similar triangular prisms is 5 to 3. What is the ratio of their volumes? What do you do to that ratio?
Square it.
You don't square
Cube
it,
it, I
you
mean.
cube it because volume is in cubic units. So that's going to be 125 over 27, done. Okay? Number 6, you're going to do the same thing but backwards. This time they give you the ratio of
Square
the
root.
volumes.
Cube root.
You don't square root it, yeah, you cube root it. So if you know the ratio of their volumes and you want the ratio of their heights, you cube root it. So the cube root of 8 is 2, and the cube root of 125 is 5. All right?
That's the answer.
And then the same thing with number 7, and the only thing you need to know here is that what does weight relate to? Does it relate to the dimensions or the area or the volume? The volume, yeah. So if it tells you the ratio of the weights of two spherical steel balls is 8 to 27, then really what they're telling you is the ratio of their volumes is 8 to 27. So if you want to find the ratio of their diameters, what do you do with these things? Cube root it. So the, yeah, cube root of 8 is 2, and the cube root of 27 is 3. Okay? So I'm not going to have time to go over the rest of these, but we can get you started with number 8, and then hopefully that'll let you finish up the rest. 8 says the energy and cost needed to operate an air conditioner is proportional to the volume of the space that is being cooled. Okay? So they have a small space that they are able to cool for $125 a day. Then they have another place a few blocks away that dimensions is 2.5 times as great. Right, so if you know that the linear dimensions are 2.5 times as big, that means that the volume is going to be 2.5 cubed times as big. Okay, so what's 2.5 cubed? Anybody got a calculator in front of them?
No, what is it?
Riley, you got me?
15.65.
15.625. Okay, so if it costs $125 to cool the smaller place, and the other one has a volume that's 15.625 times as big, what do I do with these two numbers? Do not divide and multiply those together, and that means that it'll cost 1,000. Nicely done. He was right on that. Okay? Alrighty? Okay, so you have to do the same kind of thing for the rest of them, 9, 10, 11, and so forth. So if you still have some questions on those, try and do them on your own. But if you still have some questions on them, just hang on to these assignments. Don't turn them in. I'll collect them when I am back tomorrow, okay?
See you later.
The